Chapter 6, Section 4 for precalc. So if I can get through this really fast here, just using my phone and what I wrote down. So the only parts of 6.4 we're going to look at is the dot product and the angle between two vectors. So the dot product, when you actually complete this product, it yields a scalar, something we can multiply by a single value. It doesn't create a vector. We're going to do the dot product of two vectors, which yields a scalar. We use this value within other formulas or applications, but the actual dot product really doesn't have any meaning. So the dot product of two vectors, so if we had vector u right here and we had vector v, so that's component form, so we know the change in x and change in y of those two vectors. We can find the dot product, which if you see our symbol here is vector u dot product of vector v, so it's a bigger dot than normal, is found by taking the change of x of the first vector times the change in x of the second plus the change of y of the first times the change of y of the second. So that's how you actually find the dot product, which will give us a single number. So an example here, if I know u is 3, 4 in component form, and v is -2, 6 in component form, and w is 1, -1 in component form, I can find this value, which it's the dot product of u and v times the vector w. So when I do the dot product of u and v, I'm going to get a scalar. That scalar is then going to multiply to w, so I'm going to get back to a vector. I'm going to multiply a vector by a scalar. So here's the dot product of u and v. So I'm multiplying together the change of x's and the change in y's and adding, and I get 18. And then I'm going to take the 18 value, which is u dot v, and multiply that by w. So I multiply that 18 through the component form to find a new vector, which is 18, -18 in component form. Vector properties with dot product. These are pretty simple. They're ones that you should kind of logically be able to create. You see how if you just do the dot product is cumulative, you'd say. The zero property still holds. Distributive property still holds for dot product. Dot product of itself is the absolute value or the magnitude of v squared. I should say the magnitude of v squared. And then this one's a little different where you take the c, it's all multiplication, but you're doing a scalar times a dot product. You can multiply either vector by the scalar first, then do the dot product. The other thing we need to look at today is orthogonal vectors, or angle between vectors, which will give us orthogonal vectors. So angle between two vectors is what it sounds like. You're going to take two vectors and find the angle between those two vectors. So here's the formula for it. To find it, it's the cosine of theta, which is our angle between the two vectors, is found by doing the dot product of the two vectors divided by the magnitude of both vectors multiplied. And so you can see over here in the drawing that if you're trying to find the angle between v and u, you can use this formula to find that angle. So we want to find the angle between these two vectors. So we had vector u was 3, 0 in component form, and v is 1, 6 in component form. With that drawing, where if you think about u's component form, if we put it in standard position, we're just going 3 to the right, change in x, no change in y. Then the v is a change of 1 for the x, 6 for the y, so it has a vector similar to this. So we're going to find that angle between the two vectors and what that measure would be. So here's the work just using the formula written down, and then we're just going to do the dot product of u and v on top, and then the bottom is the magnitude of u, the magnitude of v multiplied together. So we do that, you're finding 3 divided by 3 root 37, which reduces to 1 over root 37. Hi, bud. Can you hold on? I'm almost done, okay? So we're going to find that angle, and we just got to use the inverse cosine, the arc cosine, to find that angle. So inverse cosine of 1 over root 37 is going to be 80.54 degrees. So that would be the angle theta between those two vectors. Orthogonal vectors is still finding the angle between two vectors, but orthogonal just means at a right angle, perpendicular. So if the two vectors are perpendicular, we know that they'd be forming 90 degrees. So this occurs only when the dot product is 0. So why does that occur? Well, if you think about the formula, knowing the cosine of theta is equal to that quotient, and that perpendicular means 90 degrees, we know cosine of 90 is 0, so we can state that this formula here really is going to be equal to 0 since the cosine of 90 is 0. So we know that that's true, and that will be perpendicular. And the only way a fraction equals 0 is if the numerator equals 0. So we really just care about if the dot product is equal to 0. If that's true, then you create a orthogonal vectors or perpendicular vectors. So example here is if these two vectors are orthogonal, or show that they are orthogonal, would be to actually plug those into the dot product. So I've taken u and v and plug those into the dot product. If you do that, you'll find you get 0. Because their dot product is 0, therefore u and v are orthogonal or perpendicular. So this is the only part of 6.4 I really need. I don't think I'm going to be covering projectiles. If there are any in your homework problems, you can read through the textbook and follow their example to try it. But on your assessments, I think we're staying with just dot product and angle between two vectors. We'll see you tomorrow.